In this video we are going to look at the cosine rule and how to use the cosine rule to calculate the length of a side. Let's imagine we're given a scenario where we've got this triangle here, and let's imagine we want to calculate the size of the line BC, which we're denoted here by A. Once again, we'll denote this by B and denote this by C. So far what we've seen is we've seen the sine rule. We've seen A over sine A is equal to B over sine B, and that's equal to C over sine C. And if we're to try and use the sine rule here, we would tick off what we know. We know B, we know C, and we know sine A. And we want to figure this out. But in this scenario, I do not have enough information to carry forward with either this ratio or this ratio. So in this circumstance, the sine rule does not work. And in this circumstance, when you're asked to calculate the length of a side, you should be using the cosine rule. I like to remember to use the cosine rule because if we have a look at the angle A, and if we're asked to calculate the length of a side, see how this angle is sandwiched in between these two lines, and we know the length of these two lines. If we're asked for the angle or the length of the side opposite that, then that should be a trigger that we should be using the cosine rule. Okay, so the cosine rule states that A squared is equal to B squared plus C squared, take away 2BC cos A. To prove this, we're thinking about Pythagoras' theorem and using some Socotone trigonometry. However, I'm not going to go into that in this video. This formula is given in your exam, so you don't need to worry about remembering it, but we just need to know how to apply it. So we're going to look at the example that we saw on screen 1, and we'll try and use that, we'll try and apply this formula to that example. Okay, so here's the example from the first slide that we were looking at. We've got the triangle ABC. AB is 20, AC is 14, and we want to calculate the size of angle BC. So just like how we did with the sine rule, what we're going to start off with is we're going to label the sides. So the side opposite the vertex A, or the vertex A, opposite B, and opposite C. What we're going to do is we're going to substitute these values into the cosine rule. To BC cos A. I know to use the cosine rule here because I'm asked to calculate a side and my angle is sandwiched in between two lines that I know the distance of. Okay, so A squared equals 14 squared plus 20 squared. Take away. This term I would very much advise you to put in a bracket. 2 times 14 times 20 multiplied by cos of 23. I've not got a space, I'll just do it down here. Cos of 23. So A squared will equal, so we find that A squared after doing it in a calculator equals 80.5172. That is what the square of A is equal to. So to calculate the length of A, we need to take the square root of this value. So we should have an answer of just under 9, and we get an answer of 8.97 centimetres to 2 decimal places. Obviously the triangle that I've drawn has not been drawn to scale. Okay, so I knew to use the cosine rule because I was asked to calculate a side, and the angle that I was given was sandwiched in between the two lines. That's how I knew to use the cosine rule. I applied the values, or I plugged in the values into my cosine rule, made sure I put this last term in a bracket, get a value for A squared, and take the square root. Okay, let's look at this example here. We've got the triangle ABC. We are given the value of the angle C, let's imagine we're asked to calculate the length of AB. To start off with, label your sides. Okay, let's look at what scenario we've got. So we've got an angle that is sandwiched in between two lines of which we know the length. Okay, that is a trigger that we should be using the cosine rule. The cosine rule is a squared equals b squared plus c squared take away 2bc cos a. However, in this circumstance, it is c which I am asked to calculate. So I'm going to have to alter my formula slightly. So instead of being a squared, it's going to be c squared equal to a squared plus b squared take away 2ab cos c. So I've just interchanged the a's with the c's in this circumstance. I couldn't use this formula here because it doesn't map with what I've got in this diagram here. So, okay, I've just minimized it slightly, but what I'm going to do now is we're just going to substitute in our values. C squared equals 1.1 squared plus 1.9 squared, and we're taking away, remember to put this in a bracket, 2 times 1.1 times 1.9 times cos of 20 degrees. So c squared will be equal to 0.8920. So c will be the square root of that value, which will be equal to 0.945 meters, and that is 3 decimal places. Okay, we're just going to look at one final example. Okay, in this final example, we're going to be looking at calculating the size of the line RQ. So just as before, we are going to label our sides. So this would be P, this would be R, and this would be Q. So we need to look at the information that we've been given. We've been asked to calculate this side here, and in the triangle, the angle has been sandwiched in between the two lines of which we know the length. And because we're in that scenario, that is a signal to use the cosine rule. So the cosine rule, as it would be given on your exam paper, is a squared equals b squared plus c squared take away 2bc cos a, where a is the angle, where everything is like where you're given the angle. However, we can see here that the angle is at P, so it's not going to be cos A, it's going to be cos P, and somebody would substitute this P here as well. So our cosine rule for this triangle is going to be P squared equals R squared plus Q squared subtract 2RQ cos P. Then we're going to substitute in our values. P squared equals 16 squared plus 12 squared take away 2 times 16 times 12 times cos of 53 degrees. So that will be equal to 168.903, and I'll take the square root of that to find out my corresponding length for P. So P equals 12.996 And if we're to do that to 1 decimal place, P would equal 13.0 meters to 1 decimal place. So the things to note here are you are given this in your exam, and you should know to use this because your angle is sandwiched in between the two sides which it's attached to, and we know the lengths of both sides. Thank you very much.